All right, by far the most common application of exponential functions is compound interest. And this is the idea of taking some money and putting it in the bank and earning some interest. And it could be in the stock market or some sort of funds or a lot of different ways you can invest money, but that money earns interest. And then that interest earns interest, and this creates an exponential process, and it's a good way to build up wealth over your lifetime, over your working life. So, just as a basic example, let's just say you have $100, and instead of going out and spending it, you invest that money. Um, in general, an exponential function, as we have discussed, is a times b to the x. What makes this different from functions we've talked about in the past is the x is in the exponent position. If if you were to invest $100, that would be your starting amount, the A. That's always kind of like our y-intercept. And B is the amount that it gets multiplied by every time x goes up by 1. If, let's say you can earn 9% interest, which I believe historically, if you invest your money in the market in some sort of retirement fund, 8-9% interest is not unreasonable. So first thing to learn is if you gain 9% interest, you need to multiply your money by 1.09. The 0.09 is the increase in your money, but the 1 is the original 100% of what you had. And if we do that every year, then X will be the years. When X is 1, we have accumulated that money for 1 year, and so on. So if I sub in the number 1, after 1 year, I have $109. And you might think, well, it's not that big of a deal, $9 in a year. And that's kind of true, but we have not started to compound yet. Next, that $9 earns 9% interest, and you each year the balance goes up, so the amount your 9% is being calculated on a greater amount every year. And over the course of your life, you're not just going to invest $100; you're going to invest a portion of each one of your paychecks. So here is a picture of what just this $100 would look like over several years. So here's the picture of growth of $100 over several years if you were to invest it and make 9%. So early on, what we were talking about, after 1 year, you just make that $9. But you can see this is an exponential function, so it really hits the point where it gets to steeply increasing. And you can see that, this is all free money. That's why it's called the magic of compound interest. All you have done is put $100 in the bank, and it has grown to, let's say this was the first paycheck you ever made of a 30-year career. That $100 after 30 years has become, looks like, over $1,300. So that's $1,200 you made for absolutely doing nothing except not spending that $100 when you had it. And imagine $100 out of your first check and $100 out of your second check. So you add all that together, and that's compound interest, and that's how you build up wealth that you can spend when you retire, and you can go sailing on your boat every day. So, if you're taking any advice from me this year, it's the first day you get a job, talk to somebody about investing your money, and when you are old like me one day, you will benefit from that, and you will be glad that you did. Okay, so the thing about compound interest is it usually doesn't get compounded. You don't get your interest just once a year. And this formula is the compound interest formula, and it's going to have 5 parts. And in a typical problem, you're going to be given 4 of those parts, and you have to find the 5th one. So A is how much money you end up with. We can think of it as the amount of money. And I don't know if I want to say this is the current amount, because sometimes we'll be talking about into the future. So let's just define it like this: the amount of money you'll have after T years. And I'm going to go ahead and get T. T is how many years you leave your money in the bank. And this formula stands for a one-time lump sum investment, not like a mutual fund where you are going to pay into it every month. We're not going to be worried about those just yet. But right now, this formula, you take a lump of money, put it in the bank, you'll be given the interest rate, how long, how many times it's going to compound per year, and that's what this formula is going to tell us. This P is for principal, and this is money at the start. This is how much you put in the bank. R is the interest rate, and you want to put it in decimal form when you are working a problem. And N is the number of compoundings per year. Now, in our last example, we just had 1.09 to the t because we were just compounding once per year. So what's going to happen is, let's say you make 9% interest. They're going to divide that 9%, and if your interest is compounded monthly, you're not going to get 9% every month. You're going to get 1/12 of that 9% every month, so that you end up getting a full 12% throughout the year. But the fact that they compound it monthly means your interest starts earning interest sooner in the year, so you get a little bit more advantage, a little bit more money growth the more times they compound it per year. So here are the unknowns, and we're going to do an example, I think 4 different examples where one of these values is the unknown each time. Okay, so this first example, kind of straightforward. You're going to invest $500, and you're going to get 4.5% interest compounded quarterly. So this word quarterly means 4 times per year, every 3 months. And you're going to leave it for 12 years. How much money will you have? So we're always just going to start out with our main formula. P times 1 plus R over N to the NT. Now the things we know in this problem are, we're starting with 500. We are making 4.5% interest, so as a decimal, 0.045. And they're going to give me 1/4 of that interest 4 times a year. I'm not going to get that whole portion every quarter. And that in 4 times 12, I'm going to leave it for 12 years. So this is the, I'd call, straightforward problem, where everything on the right I know, and the amount at the end is what I'm looking for. So I'm going to suggest that you do this a step at a time in your calculator. And so that's going to look like this on this particular calculator. I'm going to start with the 0.045 divided by 4. And just hit enter along the way. You could type it in one big swoop in a graphing calculator, or you could just kind of go a step at a time like I'm going to do here. Now I'm going to add 1. Now I'm going to raise that to the 48th power, because 4 times 12 is 48. Hit enter along the way, and I'm going to multiply my original 500, and I get 855.42. 855.42. You'll start to get an idea of what a reasonable answer is. But if I start with $500, it's not unreasonable to think that would grow to 855 over 12 years, even with a relatively low, in terms of what we've talked about so far. 4.5% is not a huge percent, but in a more cautious bank account or something like that, this is probably more realistic. But watch out for unreasonable answers. They can point out mistakes in your work. So just make sure that it seems to be a reasonable amount, and then just double check your math. Okay, so here's another type where we have a different unknown. How long will it take to double our investment if we invest 200 at 6% compounded monthly? So the thing that's not flat out given, but we can get from this info, is if we want to double our investment, then we end up with 400. Started with 200, 1 plus 0.06 over 12, because we're compounding it once a month, and that 12 is the most common value that you're going to use in that spot. How long? So T for time is my unknown, 12T, And so you can see here that our unknown t is in the exponent position, which makes this an exponential equation, which means that at some point we're going to have to use logarithms to solve it. The first thing I'm going to do is divide both sides of the equation by 400, and I'm going to get 400 divided by 200 is 2. And what you'll see is that this question actually, the amount that I start with is irrelevant. It's going to take me whether I invest $1 and double it to $2 or 1 million and double it to 2 million. No matter what, the first thing I do is divide by my initial amount, and I end up with 2 on the left. So it doesn't really matter. Now the next thing I want to do is log both sides, because I have just a power on the left and I have just a 2 on the right. So I'm at the point where I need to log both sides. So I'm going to make the left side be log of 2, because that's what we do when we need to solve an equation with an exponent unknown. So I get 0.301, and I'll use that number in my calculator. I'll just write down the 0.301. But the reason I log that is because logging makes the exponent drop out to the front. And this is what I end up with. Okay, so I need to divide by 12. And I've got 0.025, and I've gotten rid of this 12 right here. And now I need to divide by log of 1.0612. All right, and with a graphing calculator, this will be a little bit easier, but right now I'm here 0.02508 and change equals this log expression equals t times log, and let me go back to my calculator, and let's see, that's 0.06 divided by 12. 0.06 divided by 12 plus 1. So my parentheses are 1.005, and my log of that answer is this number, 0.0021, and my answer is going to be 0.02508 divided by that number. And I get 11 point, let's just call it 11.6. I didn't round early, so it's going to take me 11.6 years to double my investment at 6% compounded monthly. All right, so that's not the most graceful thing to do on a simple calculator like the one I'm using right now, but you can make sure you can do that on your own. Make sure you're able to solve this this equation on whatever calculator you're going to be using, and you're fine. Okay, so let's do one more. In this case, we need to have $5,000 5 years from now. I'm not sure what scenario. I know exactly that I need 5,000, but if I want my money to grow to 5,000, I know how much interest I can earn, and my question is, how much do I need to invest? So I need the balance to be 5,000. I do not know the principal. That's the question. 1 plus 0.07. Here we are monthly again. And 12 times 5 is going to be 60. All right. So my unknown is not in the exponent, so nothing fancy. I don't need to use logs. I just need to step my way through this process. I'm going to do the 0.07 divided by 12 first. Then I'm going to add 1. Then I'm going to raise it to the 60th power. 60th power. And so I have 5,000 equals P times this number. So I'm going to do 5,000 divided by that number. And I get 3527. And let's call it 3 cents. Usually these money questions will round to the nearest cent. And there you go. If you want to end up with 5,000, you need to have about 3,500 to invest and let it grow for 5 years. Okay, one more. You can invest 1,500, compound it weekly. You need it to grow to 2,000 in 4 years. What percentage rate do you need? Okay, so a little bit different. R is the unknown. I want to end up with 2,000. I am starting with 1,500. 1 plus, and I'm going to compound it weekly. So let's call it R over 52. And in 4 years, so that's 52 times 4. So I'm going to go ahead and call that 208 up here. With my simple calculator, it'll be easier if I just go ahead and do 52 times 4 is 208. And that's assuming 52 weeks in the year. I don't know that that's exactly the case, but it's close enough for our purposes. All right. So my unknown in the R position, I want to do 2,000 divided by 1,500 first. And I get 1.333 and so on. Now I have, at this point, 1.3 repeating equals 1 plus R over 52 to the 208. Now, the opposite, the undoing of a 208th power is a 1 over 208th power. And I'm interested to see what this is going to do to my poor little calculator over here. But I want to take 1.3 repeating and raise that to the 1 over, to the 1 over 208th power. And this might cause problems. I'm interested to see. No, not bad. So I get a number slightly over 1. So at this point I have this number equals 1 plus R over 52. So I'm going to subtract 1 from both sides. And now I'm going to times 52. And I get 0.0719. All right, so it looks like it worked out. That's about 7.2%. Move your decimal point twice. And that's a reasonable answer. So good. All right, so like I said, use your calculator. Make sure you're able to solve these equations with whatever calculator you will be using, and use the same exact formula every time. Your given info should be all but one of these values. Solve for that value, and that's it. And this is compound interest. It's what will make you rich one day if you invest.